very good questions. Let me do a quick recap of the last two questions. At least the first question. This is quite easy, but let me do a quick recap of this question. So in this question, the main idea was that it's a question where the principal itself is reducing, right? He keeps on repaying, you know, um, he keeps on repaying along the way partial amounts. So the idea is that the interest that he needs to pay has to be calculated for each year separately, and whatever is the balance principal, you know so 10% is the rate, so 10% of the balance should, so 10% of 80%, so 40% of that, so 10% of 40% or 4, then am I audible now? How about now? Yes. So 80% remains. So 10% of that 80%, which is 8%, he needs to pay, right? Audio, am I audible now? How is it possible? How is it? Everything is connected at my end. Am I audible? Am I audible? Am I audible? And this. Understand this. How about now, people? Am I audible now? Am I audible now? Am I audible? Better? Okay. So this is a very good question that came in XAT on square minus 2cx plus d equals 0, then. And the options give you to hold between these coefficients a. All of them involve square of some of the coefficients, right? To do this question, what to do? क्या करें? Hello, am I audible? क्या हो रहा है? Everything is fine. How about now? Am I audible? Hello, 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 hello. Don't understand this. Am I audible? Am I audible? Am I audible? Am I audible now? Am I audible now? Am I audible now? I'm audible now. Hello, I'm audible now. Hello, hello, I'm audible. Hello. Fine. Right. So in this question, uh, you know, uh, we have to derive some kind of relationship between the coefficients, right? The ratio of the roots is equal, right? Very interesting. Let's say alpha and beta are the roots of this equation. Let's say gamma and delta are the roots of this equation. What we are given, alpha over beta equals gamma over delta. That is given, right? And you have to derive some kind of relationship. So obviously, I mean, you have to take some, you know, you have to take some kind of a hint from the options itself, each of which have some kind of squared effect on some of the coefficients. In fact, three of the options, first, second, and third, have the squaring of a and c. Now we know that a and c are related to the sum of the roots. So in some way, we have to derive some kind of relationship such that the square of the sum of the roots comes into the picture. Okay, so this is the manipulation that we have to do. Let's say that each of these ratios is equal to k. So we are given alpha by beta equals gamma by delta. So can I mean, if I want alpha plus beta whole square kind of thing, right, and gamma plus delta whole square kind of thing. So think of this: you have alpha by beta in front of you, right? If you add the reciprocal of alpha by beta, which is alpha by beta plus beta by alpha, you would end up getting alpha square plus beta square, which is a step towards, getting closer to alpha plus beta whole square. Are you getting my point? And in fact, if you add a 2 on both the sides, if you add a 2, right, then you have exactly what you want: alpha square plus beta square plus 2 alpha beta on taking the LCM. So what I'm trying to say is that if k equals k is given, try to understand, alpha by beta equals gamma by delta is given. So is it not okay to say if k equals k, then k plus 1 over k plus 2 would also equal to k plus 1 by k plus 2? I'm taking hint from the options and I'm writing my an equation in the form to generate alpha plus beta whole square. So what I'm saying, is it not okay to say that alpha by beta plus beta by alpha plus 2 equals gamma by delta plus delta by gamma plus 2? And that will do the trick, right? So on taking the LCM, in the numerator, we very much have alpha plus beta the whole square, because alpha square plus beta square plus 2 alpha beta whole over alpha beta, the LCM, equals gamma plus delta the whole square over gamma delta. And that is what we want, right? So alpha plus beta is 2a. So 2a the whole square over alpha beta the product, which is b, equals gamma plus delta, which is 2c the whole square over gamma delta, which is d. So a square d equals c square b. That is what we can say, right? So very cleverly designed question, right? In which we had to like derive something about the coefficients. Options are the guiding thing over here, right? I don't think so we can do this. I mean, without backtracking from the options, right? Okay, right. Chaliye. Okay, a lot of questions come on maxima and minima of this kind. Let's see. Right, a lot of questions come in which the values of certain uh, parameters are given in a range, and then you have to maximize or minimize something. A, B, C are integers, mod A not equal to mod B not equal to mod C, and A, B, C lie in the range of -10 to +10. What will be the maximum possible value of this expression, which is ABC minus A plus B plus C, right? Okay, so with all these constraints, ABC are integers and they are not equal in magnitude. That is the key parameter. Each of them lie in the range of -10 to +10. So think about this, what kind of values we can take over here, right? What kind of values we can take? For example, if I take, let's say, A as 10, then B can't be 10 or -10. None of them is allowed. B can be anything except 10 and -10. Let's say I take B as -5. Now C can't be either plus or -10 and can't be even plus or -5. So basically that kind of constraint we have over here, right? With that, we have to maximize ABC minus A plus B plus C. So obviously, first thing we think about ABC, it looks like we have to take distinct magnitude of values. So let's say a good choice could be like taking them as 10, 9, 8, the highest magnitude of values, right? Now, however, there's an issue with that because I mean, this is good as far as maximization of ABC is concerned. But when you think about that, you also have to subtract A plus B plus C, right? So that's not a good job. And in fact, with this choice, if you calculate the expression ABC minus A plus B plus C, then look at this. What you get, A into B into C becomes 10 into 9 into 8, which is 720, minus 10 plus 9 plus 8, which is what, 27, and that is 693. Now that is one of the options. That is one of the options, but can we do something better? Well, think about this. You don't want to compromise on the value of ABC. You don't want to compromise on that. You want it to remain 720. Can you do some other manipulations, some smart manipulation, so that this subtraction actually does you some better job? So think about this. What if you introduce the some minus sign in two of the parameters? Let's say A and B. In the product, minus minus will still become plus. So another choice could be take A as -10, B as -9, C as 8. Your product does not change. It is still 720. But in the subtraction, A plus B plus C has become negative. So negative of negative is positive, and eventually you end up getting a better deal. So with this choice, your ABC is still 720, and minus of the sum, which is -10 minus 9 minus 19, minus 19 plus 8 is -11. So minus of -11 is +11. Now that's a better deal, 7, right? So this kind of realization. So we have seen several such questions in recent years where such kind of judgment or discretionary thinking is required. What values to substitute? This kind of maxima minima questions, right? So you should be aware of these. You should know that you have to think on your feet. You have to try different options, right? And 693 is a very good trap option in this case. All right, so things like this I think can come up. Perfect. चलिए आगे बढ़ें. Now on your last stretch, if you need help on XAT poems, then we have our module for 99 only, right? And daily dose tests, right, for your last mile, again available for 99. So just check out these in case you're looking for your last mile journey, I think you can check it out. चलिए आगे बढ़ते हैं. Now, a very hardcore question on trigonometry with lot of sine 15, sine 75, and so on. Well, let's see. So you can see these huge powers on the trigonometric values: sine power 6, sine power 6, sine square, sine power 4, so secant power 4 power 6 power. So obviously you don't know the value of sine 15, sine 75, anything at all. But this question is about a fraction or a ratio. So you have to try to simplify this, right? And perhaps you can get two conclusions. Let's see. First thing that you should think is that everywhere we have sine theta, right? Now to make use of some trigonometric result, you must have sine as well as cos, because the basic result is that sine square theta plus cos square theta is 1, right? So that is a basic fact about sine and cos. And how can I introduce cos over here? So one thing that we know is that sine of 90 minus theta is the same as cos theta, or even other way around, cos of 90 minus theta is sine theta, 1 and 1, right? So in that sense, your sine of 75 degree, right? You can see 15 degree, 75 degree everywhere. So your sine of 75 degree can be written as cos of 15 degree from this relationship, right? Your sine of 75 can be written as cos of 15. So in that sense, what we can do, this expression therefore becomes, if I just, for simplicity of writing, let me just say that I am denoting A as sine 15 degree, and I'm denoting B as my sine 75, which is the same as cos of 15 degree, just for the simplicity of writing. So this expression, can I say, will become A raised to 6 plus B raised to 6, right? Plus 6A square B square whole over, and then this is A raised to 4 plus B raised to 4 and plus 5 times of A square B square. And I very well know that A square plus B square is always 1, right? A square plus B square is 1. So therefore, now we can do some algebraic work on A raised to 6 plus B raised to 6. So can we write A raised to 6 plus B raised to 6 in this way? It is A square cube plus B square cube plus 6A square B square. And this A4 plus B4 is A square square plus B square square plus 5A square B square. Now A cube plus, now we know that X cube plus Y cube, X cube plus Y cube, we know it can always be written as X plus Y whole cube minus 3xy into X plus Y, right? So using that, if I just now again rewrite this, that this is A square plus B square whole cube, which is 1 cube 1, right? A square plus B square, which is 1 whole cube, minus 3 A square B square, this is what it becomes, into A plus B, which is 1, into A square plus B square, which is 1, right? A plus B whole cube, which is A square plus B square whole cube, minus 3 A square B square into A square plus B square, which is 1, and then plus 6 A square B square. And in the denominator also, if I look at this, then this is A square plus B square whole square, which is 1, minus 2a square b square, from the fact that x plus x square plus y square is x plus y whole square minus 2xy basic, and then we have plus 5a square b square. So can you now see that numerator and the denominator are exactly the same, right? 1 plus 3a square b square over 1 plus 3a square b square. So that simplifies to 1. So we can calculate these things, right? Sine 15, cos 15, sine 75. But of the simple are equal. Okay, next some this one. The addition of 7 distinct positive integers is 1740. The addition of 7 distinct positive integers is 1740. What is the largest common divisor of these 7 distinct positive integers? So we have to try to maximize the highest common factor of 7 distinct positive integers whose sum is 1740. Let's say the greatest common divisor is x. Okay. So let's say if we take this greatest common divisor, the HCF, if we take it to be x, then obviously all the numbers will be the multiple of this HCF. Obviously, if HCF is known, then all the numbers are multiple of that. So let's say the numbers are, x into a, x into b, x into c, and such value to g, xd, xe, xf, xg, right? Now, since the numbers are distinct positive integers, so none of these layers that I have taken, a, b, c, d, e, f, g, can be equal. All of them are distinct, and all of them are positive also. So a is not equal to b, is not equal to c, is not equal to d, is not equal to e, is not equal to f, is not equal to g, and each of them are at least 1. Each of them are at least 1. They are positive because all of these numbers are positive integers, and what we know that their sum is 1740. So can I say x times a plus b plus c plus d plus e plus f plus g is 1740. Now let's break down this number 1740. This x has to be maximized. So obviously the sum of the multipliers has to be minimized. We would want to have this sum to take its minimum possible value. But we know these are distinct positive integers, 7 of them. So what could be the absolute minimum value of this 7 integers? Obviously by taking them as 1 and 2 and 3 and so on till 7. Theoretically, this could be the smallest value, but then this sum also has to divide this 1740. Let's first of all calculate this. We know this is 7 into 8 by 2, so 7 into 4, 28. Now, is this divisible by 28? Well, 28 has 7 in it, but this is not divisible by 7 because 14 and then 34. No. So we need something else. So what we need to split this number, and we need to find its factors, and we want to assign a value to a, b, c, d, e, f, g, which is less than 28. Right? So let's do this splitting. This is 10 into 174. 174 is divisible by I think 2. So 2, and then I can see 2 into 8, 16 and 14, 87. 1 is divided by 3. So this is 10 into 2 into 3, which is 6, and then there is 29, more than 28. So what I can do? I can make this 7 as 8, and I can get this sum to be 29. So when this sum becomes 29, then this number HCF take its maximum value, which is 10 into 6, 60. So 60 is the highest possible GCD of these 7 distinct positive integers. Very clever question, right? बहुत ही अलग सा सवाल है that sum of numbers is given and we have to maximize their HCF and their distinct integers as well. Right, so this factorization concept is required. You need to understand that each of the numbers have to be the multiple of the HCF. Right. Perfect. Right. चलिए आगे बढ़ते हैं. Clear? Now, again, right, XAT 2011 question on probability, and a very nice question that came. Let's read it together. There are 4 machines in a factory. There are 4 machines in a factory. At exactly 8 p.m., when the mechanic is about to leave the factory, he is informed that 2 of the 4 machines are not working properly. Let me draw a picture for you. What is the question saying? There are 4 machines in a factory. So just physically think of, okay, I have these 4 machines lying in front of me in the factory. Let's call them M1, M2, M3, M4, right? At exactly 8 p.m. So he has had a long day. He wants to go home. But at exactly 8 p.m., when the poor mechanic is about to leave, he's informed that 2 of the 4 machines are not working properly. Do you think he can really leave? No. Okay, so what happens is the mechanic is in a hurry and decides that he will identify the 2 faulty machines before going home and repair them next morning. So he won't repair them, but at least he will identify them so that, अच्छा कल का काम मुझे पता है कि आते ही ये करना है. 20 minutes to walk to the bus stop. The last bus leaves at 8:30 p.m. If it takes 6 minutes to identify whether a machine is defective or not, and if he decides to check the machines at random, what is the probability that the mechanic will be able to catch the last bus? 20 minutes to walk, 8:32 last bus leaves, so he can afford to leave the factory at 20 minutes before 8:32, which is 8:12, right? 8:32 last bus, 20 minutes walk. So 20 minutes prior to 8:32, which is 8:12, is the last time he can afford to be at the factory premises, right? And since it takes 6 minutes to identify, so basically he has neck to neck sufficient time to only check 2 machines. He can only check 2 machines out of the 4. He cannot check all 4. What is the probability that he'll be able to catch the last bus if he decides to check? Means, what is the probability that he's able to identify the 2 faulty machines by the time he has checked 2 out of the 4 machines? Right, that's the question. Okay. So now, how do we do this? Well, he needs to check 2 machines only, right? So any probability question is favorable ways over total ways, right? So what is total ways over here? Total ways is all the ways he can select 2 out of the 4 machines. He is going to select 2 out of the 4 machines. He can do that in 4C2 ways. So he can do that in 6 ways. That is why you can see most of the options have 6, 3 as their denominator, right? So 6 are the total ways he can select any two machines randomly. Now, what are the favorable ways? Think about this. So you see, for favorable ways, think about this. Let me just label that M1 and M2 are faulty, just for the sake of discussion. Okay, I don't know which two are faulty. I'm just labeling that. Let's say these two are faulty. This is faulty. This is faulty. Now, favorable ways could be, let's say that he selects M1 and M2 to inspect. This is one of the ways, and he finds both of them to be faulty one after the other. So if the two machines he selects on the first instance, both of them turn out to be faulty, his job is done. Now, is there any other favorable way over here? Is there any more way that he can get this right? There is. What if he selects, on the other hand, let's say M3 as the first machine to select to test, he finds it is not faulty, and M4 he selects as well, and he finds it is not faulty. What does he conclude? Obviously, if two machines he has selected, both of them are not faulty, the other two are faulty. So two ways are favorable. This is the thing that, the only thing that perhaps you could miss, right? कि वो दोनों जो सही हैं वो भी select करके अगर वो उनको टेस्ट कर ले, then also he will say कि okay, these two are not faulty, so the other two must be faulty, right? So both ways he can conclude, or he can reach the conclusion that which two machines are faulty. So 2 on 6, which is 1 by 3, is the required probability, right? 2 by 6. Right, so this was this, right? Very logical, very interesting. Okay, next one. Now another very interesting question. Let's see. Very different, right? It's not a typical some theory based problem, right? Purely logic based question. So you can see something about Amit, Ben, Chitra over here. True, true, TTFF. What is this? In a true false quiz. So it's a true false quiz. 4 marks are awarded for each correct answer, and 1 mark is deducted for each wrong answer. Plus 4 minus 1. Amit, Ben, and Chitra answered the same 10 questions, and their answers are given below in the same sequential order. If Amit and Ben both score 35 marks each, then we are asked for the Chitra's score. Interesting. So we have the answer key of all the 3 students for the 10 question MCQ paper with plus 4 minus true false, not MCQ, true false quiz, right? So your answer is true or false. And Amit and Ben both have scored 35. Now think about this. For getting 35 marks, how many correct, how many wrong? So you see, all correct would give us 10 into 4, 40. All correct would have given 40. This is 35. So looks very close. So 10 into 9 would have been 36, and 1 wrong minus 1 would exactly be 35. So 35 means you have got 9 correct, 1 wrong. Now focus on the answer key of Amit and Ben. If you look closely, then a lot of their answers are matching. It should happen because since they have answered 9 correct, so their answer must also be the same, right? Now look at this. Amit and Ben, when do their answer keys do not match? Let's say it does not match in this question. Look at this. The third question, they have answered differently. So one of them must be correct, the other must be true. The other person must be correct, right? One person must be correct, the other must be wrong. Because the answer, it's a true false quiz. So you're either right or wrong, right? There are no 3 options, 4 options. Likewise, this 5th question also, you can see they have answered differently. Again, one of them must be correct, the other must be wrong. For all the 8 other questions, T, 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 F, F, T, T, F, F, T, 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 F, F, they have answered the same. So it means These are the correct answer keys we can deduce, right? These are all the correct answer keys. Now, what about these? What about between these two? What is the correct answer key for question number 3 and question number 5? What is the correct answer key? I don't know. I really don't know. Why? Because you see, whatever might be the correct answer key, one of them is true, the other is false. I mean, one of them has answered correctly, the other has answered wrongly. So the answer key is FTTF. You see, whatever be the answer key, actual answer key, at the end of the day, one of them is going to be right, the other is going to be wrong. So we cannot deduce what is the correct answer key. But look at this. Ben has answered TF and Chitra has also answered TF for those two questions. So although we don't know the answer key for the question 3rd and 5, but we know that since Ben has exactly answered one of them correctly, so Chitra would also have got one correct out of these two questions. For the remaining 8, we can just check based on Chitra's answer key, how many of them are correct for the other 8. That should get us to the number of correct questions answered by Chitra. Right? So Chitra has answered first question correctly because, right, we should just match with them. So yes, matching TT again, she has answered this correctly. FT, this is not correct. TF, this is also not correct. FT, this is also not correct. TF, this is also not correct. TT, this is correct. FT, this is not correct. So 1, 2, and 3 correct out of these 8, and one of these 2 correct. Overall 4 correct. So 4 correct and the remaining 6 wrong gives her a total of 4 into 4, 16 minus 6, which is 10. That's your choice. Right? Okay, so wishing you all the very best, people. Right? Uh, just go with your full your energy. I would say. Right? You have done what you have on